Okay, so why did we do all that remainder theorem and factor theorem stuff in the previous two lessons? We did it so that we can do this. Graph these polynomial functions. Because right now, all you know about the graphs, if I've given it to you and you've told me some properties. That's all you guys have known right now. But if I give you the function, how do we go about graphing? Well, you remember in grade 10, when we graphed lines, we used y equals mx plus b. Found the y-intercept, found the slope, graphed it. Last year, grade 11, we did quadratic functions and graphed parabolas. We found the vertex, and then we found if we went 1, 1, or 1 down, 1, etc. Polynomial functions, we need to find the intercepts and then think of how the graph behaves between them. Okay? So in order to find the intercepts, these always have to be in factored form. So the first thing I'm going to do is I'm going to have to factor this. So I'm going to have to try a number that when I plug it in and calculate, plug it in for x and then calculate the function, I get 0.
1.
1? Start 1. So 1 cubed minus 4 times 1 squared plus 1 plus 6. So that gives me 1 minus 4 plus 1 plus 6, which is not going to give me 0. This is going to give me negative 2. This is going to give me 4. But notice that these were different signs. They could make cancel out to nothing. So why don't I try negative 1? So that gives me negative 1 to the third minus 4 times negative 1 squared plus negative 1 plus 6. That's going to give me some minuses here. That this is looking promising. So, oh, sorry, it should be cubed. Negative 1 cubed. So that's negative 1. Negative 1 squared is positive 1 times minus 4 is minus 4. Minus 1 plus 6. Yeah, that's going to work out to 0. So x subtract negative 1 is a factor for x plus 1. Okay, so to find the other factors, I got to do some synthetic division. So I've got to take the minus 1 that I just tried successfully and then divide it into this. So 1 minus 4, 1, 6. Bring down the first one, times, place, add, times, place, add, times, place, and add. I do get 0. So what does this become? X squared minus 5x, which now I can factor using, because I know how to factor these ones. Should be pretty automatic for you guys. Negative 2, negative 3. So I'm just going to write it up here. Okay. Now what we're asked to do is we're asked to make this 0 and find the roots. Remember, roots means the same thing as solutions. So when I set this equal to 0, I'm going to get 0 equals x plus 1, x minus 2, x minus 3. It looks similar to a quadratic equation that we solved in last year, but it's got 3 factors. Well, if any one of these work out to 0, it doesn't matter what the others are, this whole thing works out to 0, right? Which means it would be a solution. What value of x would make this 0? That's a solution. Because -1 times whatever these are, or sorry, this is going to become 0. It doesn't matter what these are. The whole thing's 0, and that's an answer. +2 and +3. So that's how we solve a third degree if it's in factored form like that. What are the x-intercepts? Well, how do we find the x-intercepts of any function? We make y equal to 0, don't we? Well, if we make y equal to 0, and remember f of x and y are the same thing, don't we get the exact same equation again? Yeah. So that means that the x-intercepts are going to be -1, 2, and 3. And what's the relationship between the roots and the x-intercepts? They're the same. They mean the same thing. So we've got 3 points on the line now. Well, we've got 3 points at this graph. -1, 2, and 3 on the x-axis. So I can actually put these down here. I'm going to put -1, 2, and 3. Those are 3 points on the graph. What's another point I can find on the graph? The y-intercept. How do we find the y-intercept? Well, we just make x equal to 0. So that means y is going to be, scroll up. What's the original? You can plug it into this and calculate, or you can plug it into this. Doesn't matter which one. I like this one because don't all these become zeros? So 0, 0, 0, 6. That's the y-intercept is 6. That means I got another point. So I got 4 points. The only problem is I don't know what the graph looks like. I do know that when we get x to the third, it looks something like this, or something like this. And if we get x to the fourth, it looks something like that, or something like that. It's going to be one of those squiggly things. But I got to figure out exactly how. So what I'm going to do is I am going to take the x-axis, pull it off the graph, and make it bigger here. So I'm going to get -1, 2, which is about here, and 3. So that's all I've done, is I've taken the x-axis and isolated it. So I need to know, like, I know that my graph is going to go through all these points. But the question is, like, does my graph go like this? Or does it go like this? I'm not sure. Okay. I do know that it'll, like, if it goes down like this, it's going to go through up here and probably hit that. Okay, but I'm not sure. I got to figure out, is it above the x-axis, positive, or is it below? How do I test that? How do I see whether it's above or below on this side, -1? Test the point. Give me a value that's lower than -1. Give me an easier one. -2. Just try the one next to it. If I plug -2 into the function, so if I plug -2 into this, if it works out to be positive, that means it's above. If it works out to be negative, that means it's below. So when I try -2, I'm going to plug in -2 plus 1. -2 plus 1 times -2 minus 2 times -2 minus 3. By the way, you can cross these out. I'm not even going to do this. Don't worry about this. Now, I don't care what the answer is. I only care whether it's positive or negative. Because if it's positive, that means it's going to go up the graph to the left here. If it's negative, that means it's going to go down. So I don't care what the answer is. So I'm not even going to bother calculating. Is this positive or negative? Positive or negative? Positive or negative? And so I'm going to have a negative times a negative times a negative, which means negative. Which means everything to the right is below. It's below the graph. So that means the first section looks like this, right? Everything to the left of -1 is below. Then it goes like this, right? Like I can follow the pattern. So it's got to go through it. Where do I have to go through next? I have to go through this because it's part of it. But then it's got to turn back down and head towards the next one. So it comes back down, hits the next one, and doesn't it continue to go through? And then it's got to curl back up and go through that. So notice I went from negative to above, to below, to above. And we don't need to be perfect. I have no idea how low this goes. It could have gone lower. It could have been shorter. We're sketching. We're sketching the graph. We're not being perfect. Now, all that being said, this would be a really heavy question, asking you to factor the whole thing and then graph it. What usually happens Yeah, go ahead. If I went like this, oh yeah, no, it's got to go below, because aren't x to the 3 and x to the 4th always curved? Yeah, so it can't go and then flat. Yeah, it's got to be a series of curves. Here's something that would be common. And it would be, we're not going to get to it yet because there's one other thing I got to talk about, but oh no, we're not going to talk about it just yet. It would be on the 3rd page. Yeah, like this would be common. Given a question, you're given it in factored form and you have to figure out the graph. Okay, but let's go back. Because the one that we just graphed, looked like this, right? So it was, I mean, it wasn't, this one would be goes to -2, 1. So our x-axis would look like this. We'd have -2, we'd have 0, we'd have 2. Notice it's below, so it's negative. Then it goes above. Then it goes below 0, and then it goes above. Sometimes, however, and this is not really a great math word, a curve will bounce back on the x-axis, like this. Okay? Notice this one, if we did -2 and 0 and 2. It was below, right? It came up, it hit the -2, but then it bounced back and stayed below. And then it went above. Oh, positive 1, sorry, x. Yes, positive 1. Oh, yeah. So this one, well, this one acts kind of really weird. It goes through. So there's only one x-intercept at 3. It's below, and it goes through and becomes above. But see how it goes through kind of weird? Like it kind of flattens out and then goes through. Okay? All of these, this function, if one of the intercepts is -2, that means one of the factors must be x plus 2. 0, that means one of the factors must be x. 2, one of the factors must be x minus 2. But we would write the x in front here. That's how we would write it. But I'm going to just leave it like that. Okay? Notice that all 3 factors are different. This one would have the equation x plus 2 squared times x minus 1. Notice something? That's the equation of this. Because it bounced back at -2, that means that there's 2 plus 2's. So whenever it bounces back, that means that a factor is going to happen twice. And what happens if it flattens and goes through? Well, this is really weird. This is actually means it's cubed whenever it flattens out. Make sure I give you. And we call these things, like if a factor doesn't appear twice, it just goes through on the graph. If a factor appears twice, it bounces back. It could bounce like this, or it could bounce like this. If it flattens out and goes through, it's a cube. Okay? We refer to that as multiplicity of a zero. Remember, zero means the same thing as x-intercept. Basically, what's happening at the x-intercepts? Okay? So the multiplicity refers to the number of times a zero or x-intercept occurs. So that means that this x-intercept of -2 here has a multiplicity of 2 because it occurs twice. This one has a multiplicity of 3. If it doesn't repeat, they all have a multiplicity of 1. Yeah. Oh, sorry. So the first one, they all went through, didn't they? So all of these would have 0. All of these would have 0 of multiplicity 1. Because they all went through, and these are all different. None of them appear twice. This one has a 0 of multiplicity 2 at this x-intercept, but a 0 of multiplicity 1 at this x-intercept. It bounces back or occurs twice in the equation at -2, but it goes straight through and only appears once at +1. This only has one x-intercept, and what's happening? It's flattening and going through. That means it's automatically 3. Well, you have to explain the multiplicity of each x-intercept. Oh, no, you don't. No, you just have to put, because it only happens once, right? There's only one thing happening, and it's multiplicity 3. Okay. So this kind of repeats what I just talked about. Okay. What x-intercept does this have? Does this root repeat? What x-intercept? Like what's the x-intercepts of this function? -2, because it's all the values of x that make this 0. So the x-intercepts are -2 and +1. And it repeats at the x-intercept -2. If we do a sign diagram, that's when we just draw the x-axis, the intercepts. That's what they call it. What's happening here? Is it above or below? Well, try a number beside. What number is smaller than -2? -3. So put -3 in here and see if the answer is plus or minus. I don't care what the answer is. Just see if it's plus or minus. So -3 plus 2 times -3 plus 2 times -3 minus 1, those are all negative. That's a negative times a negative times a negative. That means that it's going to be below, right? But remember, if an intercept appears twice, it bounces back. It doesn't go through and change sign. It stays in the negatives, doesn't it? And notice that's what's happening down here. This has a multiplicity of 1. It doesn't bounce back. It goes straight through. So it goes from below the x straight through to above the x. It becomes positive. So when we have multiplicity 1, the sign doesn't change. It doesn't go from positive to negative or negative to positive. However, if it's multiplicity 2, it bounces, which means it stays below at negative or stays above at positive, depending on the question. Right? And what happened there at x equals -2? It bounced back. Or stayed negative, bounced back. So we got to be careful when we see those. But here's a question that you're going to have to be able to. One like this. And this is the last thing we're going to do here. So this is a very common question. It usually appears on the provincial every year. But obviously different numbers. So where are my factors? I've got 1 here, 2 here, 1 here, and 1 here. So I've actually got 5 factors. Because this one appears, this one happens twice, right? Don't forget, x, negative x is a factor itself. So to graph this, find the x-intercepts, find the y-intercepts, see how it goes above and below or bounces back, finish the graph. So I know it looks pretty complicated when we were working on the last 2 pages, but this will make it a little bit easier. This is really what you just need to focus on. What are the x-intercepts? What are the values? Because remember, x-intercepts, this becomes 0. What value of x makes this 0? This one. This one? This one. Okay, so those are, I can put them on my sign diagram. 0, 1, 2, 3 is out here. -1, -2 is here. Got 1. I've got 3. And I might as well put them here. 1, -2. Here. 1, not a 2, but a 3. Remember, it's going to go something like this. Okay. So we got that. Now, we got to find the y-intercept. How do we find the y-intercept? We do the opposite. We make all the x's 0. And calculate. So to find the y-intercept, it's going to equal -0 times 0 minus 1 squared times 0 plus 2 times 0 minus 3. What's that? Yeah. Right? It's 0. Because it doesn't matter what all these are getting multiplied by 0. and then you put a negative in front of 0, it's still 0. So that means, well, this point serves two purposes. It's the x-intercept and the y-intercept. Okay, now I got to figure out whether it goes through or bounces back and whether it starts above or below. So I'm going to go furthest left. I'm going to try a number to the left of -2, -3. Now you got to be careful here because you're going to plug -3 in. So it's going to be -3 times -3 minus 1 squared times -3 plus 2 times -3 minus 3. And again, I don't care what the answer is. I just care whether it's positive or negative. What does this become? Positive. That's positive there. What is this? Positive, because as soon as I square this and this, so a positive times a positive times a negative is positive. So that means here it's up. Now remember, if an intercept happens twice, it bounces back. So I'm going through -2, which is x plus 2. Does that happen twice? No, so it goes straight through, gets into the negatives. So it goes down, starts to come back up towards 0. Okay, does the x occur twice? Nope, goes straight through. So it curls, starts coming back towards 1, which is x minus 1. But it's squared, right? That means it bounces back. So this means bounces back. So it stays in the negative, or in the positive, sorry. Stays in the positives, but then it eventually curls down again, comes through -3 or bounces back? Through, because the -3 only happens once. So now you got to put all that on the graph. Well, this tells me this. Then it goes through, right? Curls back up, starts heading towards the next x-intercept. Does it go through this one? Yes. Positive. Then it eventually curls back down, starts heading towards this one. Does it go through or bounce back? Bounces back. So it eventually curls back down, starts heading towards the last one. Doesn't bounce back, goes through. That's the sketch. Okay. I would really suggest, really suggest that you try number 3A right now in exercise 3.4. I'm going to get you to change 3B. I'm not going to make you factor 3b. I'm going to give you the factor form right now. So the factor form is x plus 1 times x plus 4 times x minus 2. So make that change to number 3b on exercise 3.4. Because that's really what you're going to see. You'll be given it in factored form. If you're asked to factor, it'll be a separate question. And it won't be a graphing question, I'm sure of it. So remember, when we work through this one, we need x-intercepts and the y-intercept. And then we need our x-axis. Should be able to tell me what the x-intercepts are. They are all the values of x that make the factor 0. So what value of x makes this 0? What value of x makes this 0? What plus 1 is 0? Negative 1. What are the other two factors? 2 and 3. So I got this already. I know those are points. Got to find the y-intercept. So that means I turn around and make x equal to 0. So I get 0 plus 1 squared times 0 minus 2 times 0 minus 3. I'll let you figure that one out. Give you a minute to figure that one out. And we can put, I got negative 1, 2, and 3. Anybody got the y-intercept? What? Positive 6. Positive 6? Did you get positive 6? There you go. Just messing with your heads. Be confident, you guys. Okay. That's right. Okay. So I know all my curves are going to go through those 3 points. Question is, starting on this side, does it start below or does it start above? So this is where I got to come over here and try a number to the left of negative 1. Again, plug it into the original factored form. I don't care what the answer is. I just care whether it's positive or negative. Negative 2 plus 1 squared. Yeah, as soon as you square anything, it becomes positive automatically. Negative 2 minus 2. Negative 2 minus 3. So my final answer is going to be positive or negative. So that means it's above. That means it's above. It's going to look something like this. Now, I got to see whether it goes through or bounces back. It bounces back because at this x-intercept, it has a multiplicity of 2. So this tells me that it bounces back at negative 1. So that means it's going to stay positive. That means it's going to bounce up. Now it's going to go up and come back down. But it's got to go up high enough to get through this, right? So it's got to come up here. And then eventually we'll come back down and start heading towards the next x-intercept. Through or bounce? Through, because this doesn't appear twice. So it becomes negative. Rolls around, starts to head towards the last one, goes through. So it changes sign, becomes positive, becomes positive. And that's the way your graph looks. Okay. So you should definitely be able to do 3B. For Friday, I'd like you to do exercise 3.4, except do not do number 4. We haven't covered it yet. Do not do number 4. We'll finish ones like number 4 on Friday, and that will take care of this unit.